Man, with finals coming up, I'm just really stressed out. Don't have much time to, do stuff. But
I know. It's supposed to snow tomorrow, though.
oh, that'd be sweet. Like, I love doing stuff in the winter. Just
Yeah,
like
we should
in
go
the snow.
sledding.
Oh, that'd be so much fun.
Yeah.
We should do that.
Down the hill, it looks like Ruben is in the lead, and here comes out. And this.
Oh, jeez! Oh, jeez!
It was a bad idea. At Riverside Park, Rob Weth, Global News.
Sledging yesterday.
It was good, except I ran into Charlie, put him in the hospital.
Oh, really?
Yeah,
Too-
he's going too fast. Didn't see him.
That sounds terrible.
It's really unsafe.
We should definitely take a closer look to it. What
I agree.
exactly happened so that
It's
it doesn't
unsafe.
happen again.
Yeah.
6 hours later.
Okay, so a little closer look at the sledding incidents yesterday. So we drew up a little mock diagram here of Allie sledding down and hitting me standing at the bottom of the hill. So we assumed just a height of 10 meters, and we assumed a couple other mass of 50 kilograms, and then a couple other assumptions that Allie started from rest, so T1 equals 0. Then all the energy was converted into kinetic energy at the bottom of the hill because there's no spring, and then our height equals 0 at the bottom of the hill. Then both of our masses are constant, and the only acceleration is the acceleration due to gravity. So then we get to our conservation of energy equation, our governing equation. And so from our assumptions, our kinetic energy at 1 is 0, and our potential energy at 2 is 0, which derives down to mgh plus the work from 1 to 2, which we don't know what that is yet, equals 1/2 mv squared. So the work from 1 to 2, initially we're going to assume it's frictionless, right? Because we're sledding on some ice, so there's really no friction that we can account for. So then you plug and chug, we get a velocity equals 14.1 meters a second, which is really, really fast out of this cruising. So it's worth noting that we're assuming in our problem that we're basically going straight down, which is obviously not how you sled in real life, which is why we get a number that's so high. So what could Allie have done to harm me less? We thought she could have tried to slow herself down. So if you're on a sled, right, you're sledding, you're trying to go fast as possible. If you're trying to slow down, put your hands and feet out and start dragging the snow. You'll go a little bit slower. So based off of that, we assigned a coefficient of kinetic friction of 2.5, and we use the same equation of mgh plus the work from 1 to 2 equals 1/2 mv squared, but then we just plugged it in for the force of friction as the source of work, which then once you plug and chug that, you get your velocity of 11.4 meters a second, which is a difference of about 6 miles an hour total if Allie would have tried to slow down. So this is our conservation momentum equation for linear momentum. So what we're mostly concerned about in our problem with the sledding incident is the impulse, because the two momentums don't really matter if you're just trying to be safe and decrease your impulse. So impulse is the force per unit time. So in a normal collision, this is kind of what it looks like, where you don't really have a force for a long period of time, and then when you have your collision, you have a great force, and then you go back down. So what we want to try to do is extend that force out so it's a lower force, but you feel it for a longer period of time. So what we were thinking about in the sledding hill is, instead of kind of curling up and bracing for impact and protecting yourself, if you put your arms out and kind of use that almost as your crumple zone, like we talked about with cars and vehicles, to elongate that period of time that you feel that force for, so almost like you're kind of receiving that person in and trying to really brace yourself for the impact. We think that can substantially help you kind of feel less impact and stay safer.
Now that Charlie's gone, I don't think this would have made much more of a difference, because putting your arms out, it would have only broken my arms, and it wouldn't have increased the time that much. This looks like the safer way.
I definitely agree with you.
This would have just only gotten us both hurt.
That's true.